Today we're going to be going over generics, stacks, and queues. A generic class is a class where its data type can be chosen each time an object of the class is created. An example would be an array list. An array list is a generic class. Array list angle bracket string angle bracket names equals new array list angle bracket string angle bracket parenthesis parenthesis semicolon. So what that does, it creates an array list that can only hold strings. Generic classes are created with one or more type variables. A type variable is a variable that stores a type instead of a value. When objects are created from a generic class, you may set each variable type, or you may set each type variable. Alright, when writing a generic class, you list the type variables after the class name in angle brackets. The type variables are typically a single uppercase letter. Example, a generic class with one type variable. Public class, example 1, angle bracket T, angle bracket. This creates a generic class with one type variable. And an array list is a generic class with one type variable. Further down, we have a generic class with two type variables. Public class, example 2, angle bracket S, comma, T, angle bracket. So we're creating a class that has two types that would have to be set. When naming the type variables, we can set parent classes and interface. Example, a generic class where the type variable must be a string. Public class, example 1, angle bracket T extends string angle bracket. So like array list can have any type of object in its angle brackets. But example 1 here, the type that you send when constructing an example 1 object would have to be a string or extend string. Alright, another thing to make sure you know is when you say that your class variable must implement an interface, we don't actually use the words implements, which is kind of weird. So public class example 2, angle bracket M extends comparable angle bracket. And comparable is an interface, so you would think that you would use the word implements, but you don't. Use the word extends. Generic example. I like that, generic example. In generic classes, a type variable can be used where type variables are required. Example, private T data. Data is going to be whatever type they send in the angle brackets for the type variable T. So you've seen this when we did array lists and we said, oh, the get method, it returns public get int x. And the int x is the position which you should go to get something, and e is the type of data you're going to get back. And that type varies based on how you created the array list. So here, the type that you get for the return type of get data varies based on what they set the type variable to. Alright, a mutator for data. Public void set data, t data, this.data equals data. Now we're moving on to stacks. Stacks are basic structures that represent items being stacked on top of each other, like a deck of cards. When items are added to a stack, they are placed at its top or front of the list. We're going to be creating our stack with an array list, so when we add items, we're going to add it to the front of the list, position 0. The top item is the only one that can be accessed, modified, or removed. Once a top item has been removed, the item below it becomes the top item. The term for this type of access, it looks like my face is a little bit in the way, so let's move my face. The term for this kind of access is last in, first out. So if I ask you, what does LIFO stand for? You would say last in, first out. What kind of structure uses LIFO? Stacks. And the reason it's last in, first out, you could say, oh, I have a deck of cards. I have the ace of spades. Oh, I'm going to put it on top of the deck. It's the last thing that went into the deck. And then if you were to pull a card off the top of the deck, the last thing to come out, the first thing to come off the deck, if you started taking items off, would be the ace of spades. That's why it's called last in, first out. Stack constructors. Stacks will have a default constructor that constructs it to have no data. So when we make our stacks, our default constructor is going to say the stack is empty. Methods that we're going to be using. A toString it'll return a text version of the data stored in the stack. The first item is the item that's on top of the stack. The last item is the item that's on the bottom of the stack. We're going to have push, and I put here E. So push item E. You take an item and you put it at the front of your list or the top of your stack. It adds the item to the top of the stack, and it returns that item. So it's kind of weird, but that's what push does. I say, hey, can you put 5 on the deck? And it would return the object 5. That seems a little bit weird, but that's what it does. Peek returns the item at the top of the stack. It does not remove it. So when you peek at something, you get to know what's there, but it doesn't go away. Pop removes the item from the top of the stack and returns it. So this actually takes the top item from the stack. Boolean empty returns true if it's empty, false otherwise. That's pretty self-explanatory. Int size tells you how many things are in the stack. Now, normally we only do access on the top item of a stack, but if you're doing a game or you're doing some sort of program where it might be beneficial to know what cards at a specific position or what items at a specific position in the deck, we have need for a get method. We will use get to access different things, but you should never change anything other than what's at top of the stack. All right, so now we're going to do the stack example. Stack string stack equals new stack string. The first thing we're going to do is put Bob on the stack. So Bob goes on. He's at the top of the stack. Now we push Happy. Happy gets put on the stack, position 0. So Happy, it's Happy, comma Bob. Happy's on top. If we were to peek, we would see the text Happy. It would not remove anything from the stack. A peek just gives you access to data. If we were to peek again, we would still see Happy. Because again, we're just accessing the data, not pulling it off. If we were to print the stack, it would be Happy, then Bob. If we were to pop, stack.pop. Oh, I forgot to put the word peek before that. So this should be peek colon happy, peek colon happy. And this one should be pop colon happy. If we were to print the stack here, we would just get Bob because Happy left. Now if we push Joe, our stack would be Joe, Bob. And then if we were to print, we would get Joe, Bob. Queues. Queues are basic structures that represent items in a line. When using a queue, items are added to one end of the list and items are taken from the other end of the list. The first item added to a queue will be the first to come off of the queue. The term for this kind of access is first in, first out. Queues represent like lines in a store. If you're the first person to get in line at a checkout, you were the first person to leave because you were there first. Everybody else gets in behind you. So the idea of this is everybody that's new gets added to the end of the line, and whenever you take somebody from the line, you take them from the front. Queues have a default constructor that constructs it to have no data. Queue methods. ToString returns a text version of the data stored in the queue. Boolean offer E item adds the item to the back of the queue, and it returns true because there's not going to be any space or error issues. So when you write this method, you can just have it return true. Add is the exact same thing as offer. There's just two terms for the same thing. So add can even call the offer method because all it is doing the exact same thing. Don't write the code twice. Adds the item to the back of the queue and returns true. Peek returns the item at the front of the queue. Note, for us, the front of the queue. For us, the front will be the front of the array list, position 0. So when you peek, it returns the item. It doesn't take it away. Element is the same thing as peek. Again, just call the peek method. Returns the item at the front of the queue. Poll actually removes something. So removes and returns the item at the front of the queue. This is where you're standing in line, they check you out, they tell you to leave. Remove. There's two names for pull. It's pull or remove. And this should be a lowercase r. So squiggle, lowercase r. Removes and returns the front item in the queue. Boolean, empty. Returns true if the queue is empty and false otherwise. Int size returns the number of items in the queue. Get x returns the item at position x. We're only supposed to have access for removing at the front of the queue. We're only supposed to have access for adding at the back of the queue. But we do need a get method in case for some reason our program needs to access the middle items.
You may notice the camera went out. That's because I'm finishing these slides at home. I'm on the last two. Alright, let's get this example started. Basic queue string equals a new basic queue. If we were to offer Bob, Bob would be put at the front of the line. And then offer Happy, Happy would go at the back of the line. If we did a peek, we'd get the text peek. Well, we don't get the text peek because we're doing a peek, because we're getting the text peek because it's part of my system.out.print. Alright, so we're peeking. So we say peek, and then we do q.peek, which will get as a result Bob. Now it doesn't actually remove Bob from the list, so it says peek Bob. So when we peek next time, Bob is still going to be at the front of the list because we have not modified the list, because peek does not modify the list. When we go to print, we would still get Bob, Happy. Bob is still at the front and Happy still in the back. If we do a poll though, a poll looks at the front item and removes it. So when we get poll Bob. Then when we print the queue, we get Happy, because now there is only one person in the list. And to show that, let me go ahead and mark this guy out. He's no longer part of the list. Then if we offer Joe, Joe would go behind Bob because Happy is the one that's been here the longest, so he's now in the front. When we print, we get Happy, comma, Joe. Happy's in front, Joe's in back.